right, hopefully we're recording. So routers can do a lot of things, and this is kind of where we left off, was what does a router do? In the case of your home device, that router is typically combined into that gateway. It's got a wireless point. It's got a couple of network switches. It's got everything all in one. If you're getting a gateway slash router slash device from an internet service provider, it may even have phone ports in it. So if you get one from Spectrum, or the one I've got recently from Allo, has phone ports and video out and all kinds of things. What a router really does, though, is it connects dissimilar networks. And that's the key to all of this, is we're hooking together things that are dissimilar. So not only is maybe we have internally, we all have copper. Here we have fiber. So it's not just that medium, but it's the dissimilar nature of those networks. So the internet operates a little different than we do internally. There's different types of routers for different purposes. We talked about how layer 4 and layer 3 switches can also work as a router in some cases. We looked at a router table really quickly, and a router table really says, all right, I know where this packet needs to go because I know the MAC address and I know the routing to that. So in this case, something like this guy here, if I want to get to this network printer and I'm over here on the far left top, I've got to go through either router B and router C and switch D. We make a pathway. So those routers make a pathway through there. We can do it one of two ways, that mapping or that path. So a static route says we've put in the location, we put in a route, it doesn't change. Quite honestly, there are a few advantages and a lot of disadvantages. So the few advantages, if all it does is do a simple hop from this town to Auburn to an office, sometimes we will do that. It takes away the advantages of the internet, that the internet is dynamic and able to change in case of issues. Dynamic routing says, hey, we have a begin point and we have an end point, and through some kind of algorithm, we determine what the best route is for that particular path. So if I don't have dynamic routing, if I don't have some algorithm doing it for me, and somebody unplugs a router somewhere along the line between Auburn and Peru, I'm just dead. I don't have any way to recreate that traffic or move it to somewhere different. So you can actually see what your computer has in a host table. So you have some predetermined routing things that you've built into the computer it already sees. And you can do that. There's a route command. We're not going to do that in here, but I encourage you to try it, see if you actually get anything. In most cases with Windows 10, you're actually getting only that you have a route to the router, and that's all you get. But if I happen to be on a Cisco switch, you can do that. Or if I'm on another switch that's got a command line environment, oftentimes I can actually look at that routing, and I can see that.
How far will latency? So if I have Spectrum and I hit Windows 10 and I hit...
It's only going to show you between the path that your computer sees, which is typically it ends there. Now, using a tool we're going to show you, which we've already showed you a little bit, Traceroute, we can kind of get an idea of how that pathway works. But it's dynamic. It may not be the path we have today, it may not be the path we have 2 seconds from now or tomorrow. So there's some things that go into those algorithms, and they continually evolve these algorithms to say, how do I get from point A to point B? Because from here to Chicago, there may be 10,000 different ways to get there. What is the best method? Well, we have a couple things we need to consider in here. So how many hops? Because the less hops, theoretically better. If we can look at the bandwidth, how much bandwidth? So maybe more bandwidth is better. What the delay? What the size of the packets? What topologies? Reliability. So in other words, over time, has this path been reliable for me to send traffic on? And then one we don't see a lot at the consumer side is that idea of what does it cost? And you say, well, what do you mean it costs? I'm on the internet. But on the commercial side, and if I'm going between two different internet providers, they each want to make money. And so different routes can have different costs. Now, the amount of traffic you did to get to download an email is not significant. But think of something like Netflix. If I'm Comcast and I see that everybody's going over Netflix and it's costing me money because those bandwidth links from city to city, from point of presence to point of presence, cost money. That traffic is not free, although we kind of get it at home. We get a little bucket and say, well, we have $50, we can get that for free. That traffic cost per gigabyte to the level 1 providers, so people like Comcast. So that cost can actually be an important driver in which route we take. And we don't see that internally because those costs are all the same. So there's a couple of interesting terms that we see. And this one, this idea of something called convergence, the convergence time. The time it takes to recognize that best path. Convergence on the internet is probably the closest thing you've ever seen to a miracle. That we can figure out a path from here to Chicago, and it can go 1,000 different ways, how to figure out which one is the correct way. A new link pops up, and how we work around that. So, how much overhead? In other words, how much burden, how much processing on that network does sending that traffic cost? So, to make life miserable for everybody, there's not just one protocol. Well, yes and no. But these are the ones we use internally. So if I think about internally, I can use RIP, RIP2, OSPF, ISIS, IEGRP. Try to pronounce that one. And then down at the bottom is one that's a little different, called BGP. So internally, I can use any of those protocols. Externally, the entire internet is BGP. So you even have multiple protocols on a single link from here to Chicago. I don't know why I keep using Chicago. Maybe I'm having a hankering today for deep dish pizza. I don't know. But we can use different protocols. So internally we may use one of these protocols, interior gateway protocols. So most of these are what we call a distance vector. So it really measures only the transfer length, and it says, how is that distance? What is that distance? And I base that distance on number of hops and the actual length of that transmission. The length of the transmission I can measure by how quickly I get a response. Link state says a router can communicate beyond its neighbor. So typically, the original router protocols, I could only see my neighbor and talk to them. Link state says I can go another hop or two past that, and I can calculate that entire hop. So link state, a little more advanced, but it also adds overhead because now these routers are talking to each other all the time. And then we have outside of our network. And outside of our network, those edge routers, the core routers of the internet, the only thing they can use is BGP. Now, BGP evolves constantly, but it is the only routing protocol that communicates across the internet. And that's actually probably good that we only have one. But if there's any flaws or any exploits, now we have a little bit of a weakness because we have that BGP protocol, and we've seen some flaws in it that have been exploited. And there are sometimes some companies will exploit BGP on purpose. Some state actors will exploit BGP. Wouldn't it be handy if all the traffic for China actually had to go across the ocean and go through New Jersey, where the CIA and NSA can conveniently grab all that traffic and then route it back to China again? So if we do it, it seems like it's okay, right? What if it's a foreign country? What if our traffic's all going through China to get from here to Chicago? Then we ban the app, as in the case of some of this. But what you need to know is BGP is the only way that we can transfer on the internet. If you want a career where you're in high demand, security and BGP together, if you understand BGP, you can have a pretty good career out of this. It might not be the most exciting thing in the world, but you could have a career in that very, very easily. So, a couple of things that we want to look at. So, RIP, the original interior link, was really based on hops, how many hops it took. And we think in our campus it's not that many hops. So here's a router, we hit another router, and we leave to the internet. But think about a much larger place. Think about Ohio State, the Ohio State. Yes?
Do we have a server here that
Many.
we hit before? So is a server considered a router as well? Because if it goes from my system, it goes from the router to the server, and then does it get sent from a router?
In most cases, yes. Can a server act as a router? Yes. So anything that manipulates that packet we could think of as a router. And so certainly we do have both on our campus. So from our campus, and we'll show you when we do the trace route here in about 6 minutes, we can see it actually hit that. But if I think of a much larger organization other than Peru, so I think General Electric, or I go up to Omaha and I see like the former ConAgra campus, or I go to Union Pacific. Think about all the routers that they're going to have from floor to floor to building. I can run into limits with RIP. So we moved out, and so one of the most common is this OSPF, Open Shortest Path First. And so it does a couple of things. It gets rid of that limit. It's got a fairly low overhead. It prevents loops. So one of the biggest network issues we have are loops. And this sounds silly, but if I take a regular network cable and I plug one into the network and one into the network, and it just creates a path in that network, it's actually a loop. If that network is not designed correctly, that can bring down a network. In fact, I have done that before just to test someplace, and they've got a couple wall jacks with outlets. Plug one into the other. And you may well drop that network because you've created a loop in that network. And so OSPF tries to help with that. So you've got one called ISIS. So one of the benefits of this is better at IPv6. Now there are now versions of OSPF trying to adapt to IPv6, but it scales better. In other words, it's designed to grow. And as our companies grow, not necessarily we have more computers, but we're getting more and more devices on our networks. So now we've got all these access points. We've got all these IoT devices. We've got phones. As our network continues to scale and get bigger and bigger, this might be a way we look at it internally. So, this one worries me a little bit that our book talks about it a lot, because really, this is a Cisco product. And I worked very hard to find books that were not Cisco specific. Cisco is probably the largest company in the United States in terms of market penetration of networking products and routers. That doesn't mean they're the best, but they've got a lot of proprietary ideas. This was one of them, and you're going to see some others that Cisco does. If you're looking at certificates, sometimes getting the Cisco certificates is really a good idea, simply because they have such a market piece. But they've offered some things like EIGRP out kind of in a modified form, but that doesn't necessarily mean it works really well. So I think it's kind of a half-hearted effort to share some of their research. There are other companies that have protocols and similar. So Juniper Networks. is an example of another company that's got some things out there. Palo Alto Networks. So you want to be careful when you start getting routers, for example, and switches even in that case. Are they agnostic? In other words, I can hook them to other equipment, or do they have to all be Cisco equipment? Or do they all have to be, you have to be a little careful with that. Even better with some of the Cisco stuff, Cisco's got another line of products, which I really like the products. I've gotten to use quite a bit of them, called Meraki. Cisco owns Meraki. Meraki products are really good, but there are things that will work on a Cisco product, but not on your sister product in the Meraki, which is interesting. And in fact, the command line environment, when you can get to it on both of them, are different, which doesn't make any sense to me, but such is life. And then we have the internet. So why don't we just use BGP for everything? Well, it's large, it's complex, it's slow in comparison. So in other words, my cheap little $250, $300 router isn't going to do very well trying to run BGP. It does look beyond a single hop. So it's got some interesting pieces. I can send out commands from one router to the other. They will talk to each other and say, hey, you need to avoid all the area of Minneapolis, or all those routers that are identified in an area. So it's very complex. In fact, it's complex enough that sometimes it does things we don't quite understand until we start figuring out that the NSA or somebody is playing around with it also. So in most cases, you're not going to see the underlying details. You need to kind of know what's going on. So if your company says, hey, we're going to buy a bunch of Palo Alto network gear, and you have some existing Cisco gear, part of that might be, hey, are these interior and exterior routers going to work together? Is this the best combination? Those kinds of things are what becomes really, really important. If the world were perfect, we could put in any brand of information systems compared to another. In theory, we have standards like BGP. Doesn't always work that way, unfortunately. So kind of the last piece of this chapter, or the last parts we're going to look at here, are troubleshooting. And we're going to have some of these tools we've already seen, and so we're going to show them to you again. But in most cases, there's already a set of utilities for a lot of the troubleshooting. We looked at Wireshark. Wireshark does a really great job of pulling in that data, and we can look at the individual data points, or those IP packets. But sometimes Wireshark is a little overkill, or it may not do the need that we want to. So we're going to look at a couple of them really quickly. So NetStat. So NetStat gives us some really quick information. So it says, what connections do we have that are already established? It can tell us things about our network. How long ago was it activated? Do we have some errors going on? And so it really is net statistics. It tells us about what's going on in our own device. So if I just do a netstat-f is usually the one I do, and we'll see what it looks like. It's going to have all those pieces, but there's a lot of other ones. I can look at routing table information. I can look at the processor app for each piece, so I can actually see what's taking over a network connection. So this is probably the nerdiest of all the commands we're going to look at today. NetStat. I will say this, I don't use it often enough that sometimes when I want to do something with it, I have to go back and go, NetStat, all right, NetStat, which command? But I'll show you a handy shortcut. So in almost any of these, so we're going to go to our command line real quick. So command line, CMD, and it's over in the other window again. And I want to do NetStat. And if I just do NetStat without anything, it shows me these connections. So it says, I'm connected here, I'm connected here, here. So it's got all these connections. So some of these are back to the internet. Some of these are for apps I have going. if I come back up here, well, it's on the bottom. All right, so I do an up arrow key to get it again. So I couldn't remember which protocol I wanted. So I do a /?, and that works for almost all the command line utilities. It will give me a little help page. I wish I could remember everything, but there are limits. So I can do, okay, so now I think I want to do a F. And so now it gives me a little more information. So this one I'm going to guess, here where is Amazon Web Services. That's my link back to Blackboard that I've got, I would suspect. So this gives me a little more information, but well, that doesn't look like what I want yet. I know there was one that actually showed a routing table. All right, so .r. So get down to the bottom. Instead of an F, I want to put an R in there. So this actually shows me then my computer. So remember, interface 127.0.0.1 is my computer also. So it doesn't show me anything exciting. It really just shows that links between my computer and the router and some broadcast links, and nothing too exciting at that point. All right, so maybe we need to find some additional tools. So maybe this one didn't solve the issue I had. Maybe what I want to do is actually use our friend Traceroute. And we introduced you to Traceroute. And I kind of gave you this idea because it really is a set of pings. So it goes a ping with a TTL of 1. It dies because it hits that first router, comes back. Sends out a second one with a TTL of 2. It dies, comes back. Sends one out with 3, and it comes back. Here's the one limitation, or one of the limitations with Traceroute. Correct. So it goes 1 hop, then 2 hops, then 3, and it dies and comes back. The problem is, or a problem with this is, those routes aren't static. And so what I think is the route that it's taking could very well change. This is the most likely route it's going to take. And if conditions don't change out there in the World Wide Web, it's probably the route that we're going to have. But I can't guarantee that's not the route. That's the route these sets of packets took. It is not necessarily the only route out there. But we'll look at that really quickly. So there's a couple of other issues our book says. So a lot of times there are servers that say, nope, we're not going to process it. There might be a firewall. It can't predict that that route is not going to change. So I'm going to go back to my CMD. And I'm going to do a Traceroute. But, oh man, I forgot how it works again. So /?. So I can change a couple of these things. I can force it to go IPv6 or force it to go IPv4. But I don't think any of those are really important. I'm just going to go Traceroute to bmw.com. So it first is going to come up and says, well, I'm going to go to this address. And so now you can see it took, in this case, 9 hops. So what I thought it would do was hopefully come up and say, hey, here's an address in Germany. Did it ever go to Germany? Do you think from these? I do see something really weird, that it took 244 milliseconds to reply out of that site from Akaimi. But all of those returned fairly quickly. So I'm going to try another number or another name. So I'm going to go to another one here. I'm going to click my up arrow key. That way I don't have to retype that. The .eu says it should be European Union. Let's see if we get a response back. So, first server it hits, 192.168.180.1 is my router back here. This is the router at the campus. This is the router at UNL. So it's trying to get somewhere. But as we get further away, notice what's happening to our response times. They're going up. Let's see, I may have, let's see if I can slide it down a little more. And then in that case, this one's timing out, trying to go to a couple of more. So those didn't respond, the routers in that link. But notice, look at that response time. Why is that response time so long now to send a packet back? Well, if it were a distance issue, and I'm actually going over to Europe at this point, is that going to take longer to get there? Yeah. So to actually get to this address, in this case, I'm at 150 milliseconds. It's traveling a fairly long distance. And we think of electrical signals being very, very quick, but they do take time for it to send back and forth. So that's our friend traceroute. And traceroute really gets us a couple of things. So it also hits the DNS servers. So if I get a response that says cannot find this address, and I know it's a good address, that probably tells me that my DNS, something is not working in the DNS. So what I might do is then go into the network, and I might change my DNS from my local DNS to maybe that 8.8.8.8 Google's address, and see if magically that fixes it, in which case maybe my own DNS server isn't running correctly. So it also tells me a prospective link there. And there are some that you will find much longer than this, depending on where you go in the world. So I used to try to get, there was a research station in Antarctica which works really great, and it would nearly peg it out at 30 plus hops. Problem is, there was so much traffic on some of those sites, they said, hey, let's make a version that sets in the United States. Great. And so that kind of went away. So BMW does that. They have enough traffic that BMW has a site here and one in Germany. And so depending on where you're at, it will route that traffic accordingly. So traceroute is a really great thing to try to see what's going on. If I did one, for example, to peru.edu, this one should be a little shorter, but that'll show us where our website is hosted at. And notice, oh, somebody decided they didn't want to respond to pings. So now it sent one out with a hop of 3. It's not going to respond. So
So you know exactly what it's hitting, like you know where the router is, and you know where the server is. How are we going to know that down the road? We got to type in the address.
So how do you know what's, okay, I'm trying to, so you walk into a company and you don't know any information about their network. They haven't given you anything. Yeah, you're going to use that IP config to try to figure out what they've got as a base IP addresses, what it's using for a gateway, and so then you can say, all right, now I can see that gateway at this address. If I don't have a username and password, I'm going to try, because what happens, unfortunately, is a lot of people put a router in and they never change it off the default username and password. So I'm going to go out on the web and search for, oh, I see it's a Belkin router. What's the default passwords? So admin, and those kinds of things. So yeah, so you can use these tools to figure out a lot about that network around us. So if I'm just going to cancel this one out real quick. So what he's asking about, if we have a network and we don't know anything about it, and so I go ipconfig/all, this tells me a lot about this network right here. So it says, all right, I know where my computer is at, 180.103. I know the DNS server, so I'm going to bet we have some kind of a server hosted there, because it's different than this value. My gateway is this value, so I could say, all right, now I need to see if that address shows up. So that's how we start in a lot of cases if they don't have documentation. What I'm going to argue in this class, if they don't have documentation, they've done something wrong to start with. And that documentation saves you a lot of time and effort later on. So this trace route is just another way that we can find out information. So this typically leaves the control of our network, but we can trace out and say, man, I just am losing a lot of data trying to send it to our data center in Omaha. And you might find all of a sudden your pathways have changed. And so maybe Windstream or Level 3 or somebody upstream has got a problem, and it's forcing you to route things around in a much longer path than what you normally would have. So path ping kind of tries to combine pings, and so it actually sends multiple pings instead of just sending one out and back. It's a little better, but quite honestly, I almost always forget about it and don't use it. So know what it is. It might be useful to you. I find I will use some other tools other than PathPing, to be honest. Doesn't mean it's a bad tool, it's just not one that I use quite a bit. So if I happen to be on a Linux machine or a Mac, you've got some other ones. And so TCP dump actually works really, really well. It gives you a lot of information. In fact, what you'll find is if you start getting into a lot of this networking stuff, you're going to find a lot of the utilities actually work better on the Linux side. You have that command line, and you can run batch scripts, and so you'll create them and have them ready to go. It's a worthy cause to get at least familiar with a Linux operating system and the command line, because a lot of the stuff lives in that command line environment. And again, a Mac is kind of sometimes that great idea because you can run most of them on there. So this one actually does sort of like our packet capture. It'll capture some pieces, tells you what's going on. So that's not all of them. There's all kinds of other ones out there, but these are a list of some of them. These are almost always turned on by default in Windows. They're installed, they're there. It's a great tool to just sit down at that computer and go, oh yeah, I need to do a command line, and I can do an ipconfig. Some of these are also have the ability to be an active command. So ipconfig, for example, can not only show you information, you can actually use it to reset. So I can do an ipconfig/renew, and it goes out and asks for a new DHCP command. So we can see if our DHCP server is working. I can actually do a flush, and the flush DNS says, oh, my DNS entries in my table, I'm going to flush them out and start over with new ones. So some of these are not only just an examination tool, but they can actually do something in the active sense of the word. So earlier, we talked about MAC addresses, that media access control. And we said, hey, it's burnt physically into a device. And I said, wow, that'd be great. If the world could just use those, that would be the greatest security tool in history. Because we would have a hard-coded address for every device on our network, and nobody could ever do anything wrong because we could control them based on that MAC address. Except if we can get to what's called raw sockets, we can alter that. Or in a device, we can actually alter that. And we can actually say, we're going to fake a MAC address. It's called spoofing. We can spoof a MAC address. So where does it typically happen? So on our commercial network side, we build all these virtual servers, and we screwed up somewhere and we have 2 fake MAC addresses. Oh, great. It happens at your house all the time. And where this happens is you have a Spectrum cable modem, or you want one, and you have a router. And your router is set up so that it spoofs all the MAC addresses back to 1. Because Spectrum and some of these internet providers only want you to have one device. If you have more than one device, they want to charge you for it. And so they come in and they spoof all those devices back to a MAC address. So we can do it on purpose. We can do it to solve problems. What it does is says, crap. That security idea is out the drain and we can't use it. There was a time not too long ago when if you brought things like an Xbox to our campus, you had to turn in your MAC address to the campus, the IT department, so they could put them all on the network. Well, I think they finally figured out that isn't going to be very effective, and there's other ways to do things. So most of the time when we have that issue, what I like is they call it a friendly, helpful message. Usually they panic and send some kind of distress message, or if you log in, it'll actually block out the network port. And sometimes they send no message at all. You just have a computer that you can't get on the internet, can't make any network connections, and you go, what in the holy heck, this doesn't work. Maybe the network switch is bad, and you start moving things around, and then finally you go, I should log into the switch and see if the switch has some helpful information. And we've managed to do something really dumb where we have 2 MAC addresses, and we can't have that on the network. That's kind of the basis of our IP networks. So we have an issue. So hardware failures, things like our ping, I will sometimes set up pings to go continually, and we'll see when things fail. And it usually isn't things fail completely, weirdly. They fail under load, or they fail intermittently, or even worse, it's a Windows power issue. So Windows likes to turn everything off. It doesn't always like to turn things back on gracefully. And so we'll have a server that all of a sudden it'll turn off its network card because, it wanted to power save. And so these kinds of things like pings, so I'll set up a ping continuously. Well, now it doesn't turn off because it's always getting traffic. Now we can go in and go, well, that works. Now what do I need to do? What's going on? Or I can set up a ping continually. I can see when something else dies or if a piece fails. Trace route, I can do the same thing. Am I losing contact inside, outside? Where am I having issues at? So IPv6 is really much nicer in some ways than IPv4. If you saw that traffic on Wireshark where my computer's asking, hey, who has this address? Who has this one? And all the computers in that network are all asking that same question. That's a lot of traffic on that network. So ARP is pretty busy. And it's one of the reasons we break up our networks in small little sections if we can. And we have some new tools like VLANs. Well, they're not really new, but we're using them more and more where we can do that really easily. So TCP is how we make the connections of the internet. So TCP, Transmission Control Protocol, connection orientated, has that handshake. IP not, it relies on TP to get there. It's ugly. It sounds like what you're really saying is Transmission Control Protocol / Internet Control Protocol. It's almost like you're saying, I'm going to go to the ATM machine. It's almost that bad. So you need to have a fairly decent knowledge of this to be able to troubleshoot. Are you going to memorize all those things with the frames? No. I can guarantee you're not. So what I would like to do really quick is look at a couple of things. So your assignment this week, we've got a lot of tools. And I didn't spend a huge amount of time because we keep hammering on them. So hopefully by now you know to sit down at that computer, you do an ipconfig, ipconfig/all, I can get the MAC address, I can get all the information about the network, where its gateway is, and I can start to do some problem solving. I throw them in a little earlier, those command line utilities. If nothing else in that office, all of a sudden you show up a command line utility and you start typing away, you're going to be the nerdiest person in that office. But they really are useful. We use them a lot to try to figure out what's going on in the world. So there is another tool that we can use that I really, really, really like. And I want to spend a couple of minutes here taking a look at it. And partly because of the way the world evolves, and the book is not current. So, week 6, or did I do it on the... So, make sure you've done the Common Ports video. Introduction to the Internet's probably good. If you haven't looked at it or weren't in class, you might want to look at that one. So, on the discussion board this week, so week 5 is the easiest discussion board we had all year. Week 6, though, I have to do something about Spiceworks. So this is one of my favorite tools in the entire world. And not just because of the information it gives me directly, but because of the community. There are forums on there, user forums, and I can get an answer to almost any kind of problem that I can find or think of. And so, in this, I ask you to get a free Spiceworks account, keep the forum, keep the useful tools, and we're going to install inventory tools. So, there's some other pieces to it, so I want to talk a little bit about Spiceworks. So, Spiceworks.com. So where this is interesting to me is this is actually free for the most part. What you get if you don't pay, and it's only $25 or $30 a year, is there's very little ads that come across, but they think it's worthwhile. And so you'll see some ads for Dell. Dell supports Spiceworks. Some other companies support it. This is a really great tool, and they've changed it a little bit over the years. But it does a couple of interesting things. So if I look under Tools and Apps, see if it'll stay. Yeah, come back. All right. So there are some interesting pieces that are in here. User tickets. So you can actually make a ticketing system, and you don't even have to install anything. It can be completely virtual, where your users have a website they go to create a traffic or trouble ticket. It emails you as the administrator or whoever you put in there. You can do follow-ups. You can put information, so you can track what's going on in your company. There are places, so including here at our college, that we use a trouble ticketing system. And I think, do they still use Case down there? Or do you know? You don't know? Okay. So I think we use one called Case, also supported by Dell or owned by Dell. And it's thousands of dollars a year. There are lots of them. Now, some of them have more tools than others. So I will say Spiceworks is probably one of the smaller ones in terms of all the tools. But if I'm a small company, I go in and I go, you know what, this is a great tool. You should put this in, and then you can keep track of what happens. So not only can I keep track of what's going on in that network in terms of trouble tickets, and sometimes those are important. Maybe you have an employee named Mark. And Mark is one of those special employees. We've all met Mark. Mark, every day is like a training day. And every day Mark forgets his password and has to call the IT department to reset his password. We've met Mark before. And that may be evidence to say, hey, we need to retrain Mark. And so it gives you that proof of what's going on. Hey, Mark seems to have some struggles. Can we do a training class for Mark? Now, notice I was nice. I did not say we need to fire Mark, because sometimes we replace Mark with Mark II, and that doesn't work very well. So on here on the free tools, you're going to see a couple of things that are really, really interesting. Let me get the cookie monitor out of the way. So it's got a list of, and we haven't tortured you yet with the subnet calculator, IP network lookup, remote support. So I can actually do some remote support to log into a computer on my network. Connectivity dashboard, so if I have a couple of links, I can actually monitor them. So the help desk feature, pretty slick. We can do it on our own computer, we can do it online, we can do it on mobile devices. We can track vendor contracts, pretty important. But here is the inventory program. And this is pretty important. What this does is completely free. And this will actually scan our network. All right, so luckily, no, I don't want that one. Let's do, I have multiple accounts on here to make it great. Oh, no, I don't want to set it up. I want to log in. Duh, hang on. Log in. Okay. So when I log in, now I get a couple of things. So I'm going to go back and I've downloaded that, so it's already downloaded, but I want to go look at the community real quick. I have a couple of minutes here. And I want to look at the community, because that community, if I have a question, Windows 10 activation, these are all people out in the IT field, and so I can usually find some really good information about Windows Server additions and a comparison. So maybe that's what I needed, and somebody's got a ton of information out there about Windows 10. There are lurking on these forums representatives from most of the major companies, Microsoft, Oracle. And so if you're in the right forum and they're lurking on it, a lot of times you can get a question answered from a Microsoft representative themselves. So one of them that I thought was very interesting, the last time they brought out Windows 10, all the way back in like 2018, they had a tool that said, hey, if you've got Windows 7 still, for free, you can upgrade to Windows 10. Microsoft kept that site available, and it worked, but it wasn't legal to use unless you had a license. And so people were asking the question on the forum, because they were able to log into this site. They were able to install Windows 10, but was it legal? If they had an audit, was it legal? And they were able to answer those kinds of questions on there. So a lot of information in there. So I'm going to run this inventory real quick. And I encourage you to do this on your own computer. You could do it if you've installed a virtual operating system. You are welcome to do it on there and try it. So got my UAC popped up, and so it's going to install. Where did it install at? Come here. Close some of this junk out. Somewhere in one of these windows we're installing something. Chunk. All right. So the first thing it's going to do, it says, man, I'm going to install a web server on this computer. And notice it says, it asks, what port are you going to use? Well, because we already have something on this computer at port 80, I'm going to pick a different port number. So I'm going to create a different socket. And so the one I tend to use, instead of doing 81 or 82, is I go 8080. And notice it's going to install npcap and WinCap. Those are things we already had on Wireshark. And I'm going to install this piece of software. So it's going to install, and then we're going to scan our network. And it's going to tell me every device, in theory, that's on our network. When I actually have this running on a continual basis in a corporation, it'll even go out, and I can connect to printers and other devices, and it'll send you text alerts and say, hey, printer ABC is about out of toner. You should probably order some. You can see what your users have installed for software. Because even on a network where I think I have it locked down, there is some software you can still install to drive us all crazy. But I can look for things like Windows updates. All right, so I'm going to start it and see what happens in here. Chunk. Don't save, we don't need my note there. And of course it's going to launch in the other side. Let me drag it over. All right, so what it's doing now is it's scanning through this network. So we've done a couple of scans internally. We did that ZenMap, and we scanned internally our network, and it's doing something similar. if we have network credentials, so for example, in an active domain network, we have some IT supplied administrative credentials and we put in there, it will actually talk even more to some of these computers. Because what it does is it's trying to act like it has an access to every device that's in there. So this takes a little bit of setup, but I can tell you that in a small company, this is a lifesaver. Because it's got all that information, and we can put it all in one place, and we can do that help desk system. Where I also see it, I know quite a few IT companies and businesses that use something similar. Usually they'll use a rebranded one so it looks like their own brand. So they use that trouble ticketing system very similar to that to their contracted companies. So that Nancy or Joe, whoever it is, doesn't have to call them. They just submit a trouble ticket. They type it in. Here you go. So you can set this up to actually show up on your phone and other devices. So it's a pretty handy thing. Dun, 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 dun. And it never scans as quickly as I think it should. So this is that discussion board. And this is one of those you do need admin credentials. But even at your own house, you're probably going to be surprised how many devices it's going to see. Aha. And so it says, all right, now I've done a little bit of scanning. Let me log back in. So find my cursor. And if I haven't made it mad and I put the right credentials in, yep, that's me. Still me. So now it says, all right, I don't have any Windows credentials. I don't have any Mac credentials. I don't necessarily have any printer credentials. Why is it not liking? I don't have any. Yep. I don't have any. Oh, I don't have any. Helpful if I click all of those. So for right now, when it's first scanning, it doesn't have a lot of information. The more things you can put in. So in this case now, it's already found 15 devices. And as it looks through them, it'll find more and more information. So I can pull up models. Now, because Dell supports them, on the Dells, for example, a lot of times it'll actually pull up the ID number and serial number and warranty information. In different companies, it will pull up various amounts of information. But it's a really useful tool. And so I encourage you to, you walk into your small business, something like this lets you get a control and a handle on what's going on in that company. So when I took over for a hospital as kind of their interim IT director during a build, when I walked in the door, they had no way to keep track of other than, somebody put a note on a door or they'd get an email. And so we put in a system very similar to this just so we could track what the people that were working for me were doing. And we could see that, hey, we keep having these repeated issues. And that gives you that impetus as a business to go into the VP or whatever is your boss and say, these are the issues we're having. This would solve that or help solve that and save some time and money and effort, and you can use those kinds of things. It's also kind of interesting in a corporation or a business to log in and see what exactly is on that network. What is still running? What isn't running? And find out what you have. All right, and you notice we've done this a couple of times, so I actually have a ticket, a fake one we made 2 years ago. It still shows up and says, yeah, that's not good. So it will take it a little bit to find everything in there. So if I click on the lab server, it's not going to know a ton about it. If I scroll down here, it'll tell me a few things though. So it says it's a Hewlett-Packard. It's unable to retrieve the serial number. Well, all right. But some of the Dell stuff, if I can find one, you'll see, and I can actually add then information also. So it's a great way I can store that inventory information. Let's see if I can find one of the Dells that may actually pull a little more. Well, let's try that one. That one looks like a Dell number. Yeah, that's another Hewlett Packard. Okay. So you can store information on that software. If I had put in the login credentials, it would actually tell me every piece of software that's in there. We can store licensing, and we can see what our users do. So we can get a report every week and go, Mark installed World of Warcraft again. We have to force him not to do that. All right. We kind of powered through this. Are there any questions from you guys this week? Everything's due Sunday. So you should be able to get this done. And there's a couple of pieces online. One thing I have noticed, and I've had a lot of people on the Cengage are having trouble getting into the live labs. So luckily this week you don't have a live lab. You've got one you're installing on your own computer. If you feel uncomfortable installing software on your own computer, then I would probably think about using like the VirtualBox and install a virtual copy of Windows, and you can install it that way. And that's a lot of times we do that just to make life easier for us. All right, let me close this down. If there's no more questions or no questions,